Hello viewers, welcome to my channel and thank you for watching the videos and subscribing the channel and for registering the course. ये कोर्स 29 फरवरी 2024 से स्टार्ट हो रहा है। मैथमेटिक्स ऑप्शनल पेपर 1 एंड 2। जैसे कि आप देख रहे हैं 2024 एंड 2025 लिखा है यहाँ पर। सिलेबस जो है 2023 के नोटिफिकेशन पर बेस्ड है। आई एक्सपेक्ट की सेम ही सिलेबस रहेगा इन 2024 एंड 2025। सिलेबस को यहाँ हम ब्रीफ में देखेंगे, जस्ट वी विल गो थ्रू इट बट इन डिटेल बिफोर द स्टार्ट ऑफ द टॉपिक। सिलेबस को डिटेल में देखा जाएगा अलोंग विद द बुक्स। तो आइए देखते हैं सिलेबस इन ब्रीफ। ये 2023 के नोटिफिकेशन पर बेस्ड है एंड फर्स्ट टॉपिक है मैथमेटिक्स पेपर 1 में लीनियर अलजेब्रा। सेकंड टॉपिक है कैलकुलस। थर्ड है एनालिटिक ज्योमेट्री। फोर्थ इज ऑर्डिनरी डिफरेंशियल इक्वेशंस। फिफ्थ इज डायनेमिक्स एंड स्टैटिक। सिक्स्थ इज वेक्टर एनालिसिस। पेपर 2 अलजेब्रा रियल एनालिसिस is the second. Third is complex analysis. Fourth is linear programming. Fifth is partial differential equations. Sixth is numerical analysis and computer programming. And seventh is mechanics and fluid dynamics. डिटेल में बिफोर द स्टार्ट ऑफ द टॉपिक देखेंगे सिलेबस को along with the books। तो आइए स्टार्ट करते हैं सेशन को विद द सिक्स्थ टॉपिक ऑफ पेपर 2 दैट इज न्यूमेरिकल एनालिसिस एंड कंप्यूटर प्रोग्रामिंग, और इसका सिलेबस डिटेल में देखते हैं। Hello viewers, welcome to my channel and thank you for watching the videos and subscribing the channel and registering for the course. In this video, numerical analysis and computer programming of mathematics optional paper 2 of CSE UPSC IAS will be discussed. This is for 2024 and 2025. So let's see the syllabus. This is sixth topic of mathematics optional paper 2. So as name suggests, there are two parts, numerical analysis and computer programming. For numerical analysis we will be referring SS Sastry numerical analysis, BS Grewal numerical methods in engineering. Then BS Grewal has also written higher engineering mathematics, that also is good for numerical methods, but the previous one numerical methods in engineering gives more detail. Then we have NP Bali, Manish Goyal, this also good for examples. We have one conceptual book, CF Girard, Applied Numerical Analysis. This you read for more concepts. For computer programming we will be referring NCERT books, some online material, and any another book where you find, but notes will be good enough. So numerical methods, we have solution of algebraic and transcendental equations of one variable by bisection, Regula Falsi and Newton-Raphson methods. Three methods are there: bisection, Regula Falsi and Newton-Raphson method. And this is one variable equation which we have to solve, either it is algebraic or transcendental. Algebraic means x cube plus 10x plus 7 is equal to 0, and transcendental is which is having trigonometrical functions, logarithmic, exponential functions, etc. Next is solution of system of linear equations by Gaussian elimination and Gauss-Jordan direct. So these two are direct methods when we have to solve system of linear equations, when there are many equations which are given simultaneously and they are linear. Next in this we have Gauss-Seidel iterative method. So two are direct methods and this is iterative method. Direct methods, they give solutions after a set of steps, and in Gauss-Seidel we assume one initial value of the solution and we keep on improving it by iterations by applying a set of steps called iteration, and then we get the required solution which is correct up, for example 4 or 8 decimal places. So we stop according to requirement. Newton's forward and backward interpolation, this is taken from the notification. The syllabus has been taken from the notification. So we have interpolation means where we have to find the function value, that is fx, we call it y also, at a particular value of x. This is given in between, and here we take difference between two consecutive values is same, interval is constant, and in Lagrange interpolation the interval between consecutive values is not same, means distance is distance is different, like 1 x values are 1, 5, then 15, then 18, then 25, and so. Next is numerical integration. We have trapezoidal rule, Simpson's rule, Gaussian quadrature. So we will be deriving Gaussian quadrature and deriving trapezoidal and Simpson's 1 by 3 and 3 by 8 rule. Then we have numerical solution of ordinary differential equations, Euler and Runge-Kutta methods. So Euler's method, improved method, modified method, Runge-Kutta second order and fourth order methods. Now computer programming, binary system, arithmetic and logical operations on numbers, octal and hexadecimal systems, conversion to and from decimal systems, algebra of binary numbers. So we will be doing all these operations on binary numbers. Elements of computer systems and concept of memory, basic logic gates and truth tables, Boolean algebra, normal forms. For this we will be referring NCERT books and some online. Representation of unsigned integers and signed integers and reals, double precision reals and long integers, algorithms and flowcharts for solving numerical analysis problems. For this, if you know the language like Fortran or C language, you can write your own algorithm. If you know Fortran, it is easy to write. If you know C or C++, it is easy to write. So that can be done by the help of book, or you may do yourself. After doing the class, because this is first topic we are doing in this session, I am explaining the way you may do to have better results. Once class is over and you take the notes, so write formula of that lecture in one of your notebook, all the formulas, and before the next class please revise all the formulas and go through mentally the examples you have done. So it will keep on revising on daily basis and you will be remembering the formula also. And in the end of 1 week, when you have 2 days, just go through the material and formulae of that week. So it will be helpful in revision, because once you have done 2-3 times mentally only, need not to do manually each time, and you will be able to remember them. And this formula is applicable to whole mathematics. So let's do the first topic of this, that is numerical methods, where we are going to find out solution of one variable equation by bisection method, Regula Falsi and Newton reference. Hello viewers, in this video I would like to discuss numerical solution of algebraic and transcendental equations by bisection method. Numerical solution of algebraic and transcendental equations means finding the roots of algebraic and transcendental equations. Finding roots of algebraic and transcendental equations is very important, as these equations occur in many applications of science and engineering. Zero of algebraic or transcendental equations means value of independent variable, generally x, which satisfies the equation, also known as root of the equation. An equation may have many zeros. Algebraic function. If each term of fx contains only the arithmetic operations between real numbers and x with rational power, then function fx is called an algebraic function. Transcendental function. A function contains at least one non-algebraic function, that is a logarithmic function, an exponential function, trigonometric functions, etc. An equation fx is equal to 0 is called algebraic equation or transcendental equation according to as fx is algebraic or transcendental function. The equation x to the power 6 minus 80x square plus 20 is equal to 0 is an example of algebraic equation, and the equations log x is equal to x e to the power x and 3 cos x minus x is equal to 0 are the examples of transcendental equations. Nonlinear equations involve polynomial of degree greater than 1, that is algebraic equation, or and may contain at least one non-algebraic functions, that is exponential function, trigonometric functions and logarithmic functions, etc. Many numerical methods are available to solve the equation fx is equal to 0. To solve algebraic and transcendental equations, the commonly used methods are bisection, secant, fixed point iteration, Regula Falsi, Newton-Raphson, etc. Each of the above mentioned methods has some advantages and disadvantages over another method. To compare the methods, mainly the following points are considered: rate of convergence of the method, domain of applicability, number of evaluation of functions, that is number of computations, pre-computation step, etc. Geometrically, the nonlinear equation fx is equal to 0 represents a curve in the plane, and if the curve cuts the x-axis at a point, then the value of x at the point of intersection is called the root of the equation, and if the curve cuts at many points on x-axis, then all the values of x at the point of intersections are the roots of the equation. In the given figure, there is a curve y is equal to fx, and this curve cuts the x-axis at a point, and this point is root of the curve. But a pair of nonlinear equations or simultaneous equations, for example, fxy is equal to 0 and gxy is equal to 0, represent surfaces in 3 dimensions. A point of intersection of these surfaces is the solution of the equations. Most of the time, it is very difficult to find such point of intersections in exact form. Therefore, numerical methods may be applied to get the solution. Now I would like to discuss bisection method or Bolzano method. Bisection method is the simplest iterative method to find a root of nonlinear equations, that is transcendental equations and algebraic equations. Finding a root of the equation is also known as solving the equation. If fx is continuous and real in the interval ab and fa and fb are of opposite signs, then the equation fx is equal to 0 will have at least one real root between a and b. In the figure, an interval x is equal to a and x is equal to b is given, and curve cuts x-axis at 3 places in this interval. It means the curve is having 3 roots. Now let's take one more example. Fx is equal to x to the power 4 minus 7. We calculate function value at x is equal to 0, which is minus 7. We take function value at x is equal to 1, which is minus 3. Function value at x is equal to 2 is equal to 9. Therefore, there lies a root in the interval 1 and 2. Steps for finding a root by bisection method. Let us assume that the function fx be continuous in the interval ab. Find the initial values of a and b that would bracket the root. Calculate values of fa and fb. If fa into fb is greater than 0, that is positive, fa and fb are of same sign, then no root exists between a and b. If fa into fb is less than 0, then calculate x1, which is equal to a plus b by 2, and hence find fx1. If fx1 is equal to 0, then x1 is the root. If fa into fx1 is less than 0, then root lies between a and x1, else root lies between x1 and b. Repeat the procedure till the result of desired accuracy is obtained. Here in the figure, curve has been shown and there is an interval x is equal to a and x is equal to b. Function value at x is equal to a is fa and function value at x is equal to b is fb. Now we will calculate x1, x2, x3 and so on till we reach to a root of desired accuracy. Here I would like to discuss one example. Find the positive root of cos x minus x e to the power x is equal to 0 by bisection method. Solution. Let's find the interval in which root lies. Function is given cos x minus x e to the power x. We calculate function value at x is equal to 0, which is 1, which is positive. We calculate function value at x is equal to 1, which comes minus 2.178, negative value. Thus root lies in the interval 0, 1. Now we calculate the midpoint, which is the initial approximate of the root. x1 is equal to 0 plus 1 by 2, which is 0.5. Function value at 0.5 is equal to 0.0532, positive value. Therefore, root lies in the interval 0.5 and 1. Now calculate next approximate root and repeat the process till desired accuracy. x2 is equal to 0.5 plus 1 by 2, that is 0.75. Function value at 0.75 is minus 0.8561. Now we write the calculation in tabular form. Table contains k, ak minus 1, bk minus 1, xk, fxk. K represents number of iterations, ak minus 1 is first end of the interval, bk minus 1 is second end of the interval, xk is the midpoint and fxk is the function value at xk. First two iterations we have seen in previous slide. In third iteration we replace 1 by 0.75 because function value is negative at 1 as well as at 0.75. We take midpoint of 0.5 and 0.75, which comes 0.625. Function value at this point is negative. In fourth iteration we replace 0.75 by 0.625 and take midpoint of 0.5 and 0.625, which comes 0.5625. Function value is negative here. Now we replace 0.625 by 0.5625 and take midpoint of 0.5 and 0.5625, and midpoint is 0.53125. Function value is again negative. We replace 0.5625 by 0.53125 and take midpoint of 0.5 and 0.53125, which comes 0.5156, and function value is 0.00655. Now we may stop here, or we may do a few more iterations to get a better approximation of the root, and the root value is 0.5156 and function value is 0.00655. Now if we compare values of last two consecutive iterations, that is fifth and sixth iterations, the values are same up to first decimal place, that is 5. Hence the approximate root of cos x minus x e to the power x is equal to 0 is 0.5156, correct up to one decimal place. Hello viewers, in this video I would like to discuss method of Regula Falsi, method of false position, or method of linear interpolation. As I have discussed in the video of bisection method, that if fx is a continuous function and real in the interval ab and fa and fb are of opposite signs, what will we do? We will take 2 points a and b and we will check values of function at a and b, and we will check whether they are of opposite signs or not. If yes, then the equation fx is equal to 0 will have at least one real root between a and b. Now let's see one example. Fx is equal to x to the power 4 minus 7. Now we put the value of x as 0, 1 and 2, and we will see that it is coming negative for 0 and 1, and for 2 it is positive. It means function is changing its sign from 1 to 2. Therefore there is a root in the interval 1 and 2. Now let's see this figure. In this graph we have seen that x is equal to a and x is equal to b are 2 points, and it is cutting x-axis at 3 points. So intersecting points are the roots of the curve, because here it is changing its sign from positive to negative, here negative to positive, and at it positive to negative. It means it has 3 roots. Now let's see how to derive Regula Falsi method. Here we see y is equal to fx is a curve and a and b are 2 points on it. Function value is negative at a and function value is positive at b. The coordinates of a and b are x0, fx0 and x1, fx1. Now if we multiply function values at x0 and x1, that is fx0 into fx1, that is less than 0, it means root lies between these 2 points. Now graphically we join a straight line between these 2 points a and b, or we can say chord between a and b, and we see that this chord cuts the x-axis at x2 point. From x2 point we draw a perpendicular on the curve, and this is the next point. We join b and this point, and we draw a chord between this point and b, and we see that it cuts at x-axis at x3. We draw a perpendicular from x3 to curve, and then again we join this new point and b point and see that it cuts the x-axis, and we again draw a perpendicular from this point to the curve, and we keep on doing this till we reach to the desired root, which has been denoted by the point on x-axis. Now we can write down it in general form also, and it has been represented by xm and xm plus 1. Now let's see how to write mathematically Regula Falsi method. So we write down the equation of chord AB, and this is the equation of joining 2 points. So straight line, equation of a straight line joining 2 points is y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. So here we have substituted the values of x1 y1, y2 y1, and we see this comes y minus fx0 is equal to fx1 minus fx0 upon x1 minus x0 into x minus x0. Now as we know that if it cuts the x-axis, y value will be 0. We substitute value of y as 0 and see what happens. After substituting y is equal to 0, this expression reduces to this. From here we can find out value of x minus x0 and write it down again, and this is the value of x minus x0. From here we can write down the value of x by taking x0 on right hand side with positive sign, and as we see that x is the new point, we can denote it by x2 or replace by x2 and get the new approximated root, that is x2 is equal to x0 minus x1 minus x0 upon fx1 minus fx0 into fx. We can write down this in general form also in terms of n plus 1, etc. Now what happens in this figure, we have seen that here we see that fx1 and fx2 are of opposite signs. In the figure also we have seen that function value at x2 is negative and function value at x1 is positive. So we can replace x0 with x2 and get the new interval x1 and x. We can have second case also where we can have value of x2 as that function value at x2 is positive, then our interval will be x0 and x1. We will keep on repeating this process till we reach to the desired accuracy root, and that accuracy we can pre-decide, or it may be asked in the question that up to this accuracy or these many digits we need, and according to that we will stop. Thank you. Hello viewers, in this video I would like to discuss two examples of Regula Falsi method. First example is find a root of 3x plus sin x minus e to the power x. It means here fx is given, that is 3x plus sin x minus e to the power x. Now first step is that we have to find out an interval in which root of this function may lie. It means we have to find an interval where function changes its sign. So we try it by hit and trial. Let's take x is equal to 0.3 and 0.4. The value comes negative and positive respectively. You can see here function value at 0.3 and function value at 0.4. So you may have totally different interval, or you may have one end say 0.3 or 0.4, another end may be different. But once you get an interval, you may apply Regula Falsi methods formula. So let's apply Regula Falsi methods formula, and here this is the formula where x2 is the new approximated root, x0 and x1, fx1, fx0 we have already calculated here. So now we substitute all these values. X0 is 0.3 and x1 is 0.4, and corresponding values of function also we have substituted. We got the value of x2 as 0.3612. Now we calculate function value at 0.3612. We see it is positive. It means we got another interval, so we can apply the formula again. Next example is find the root of equation 10x plus 10 hyperbolic x is equal to 0 which lies in the interval 1.6 and 3. Correct to 4 significant digits using the method of false position. Here we have been given the function, that is 10x plus 10 hyperbolic x is equal to 0, and the interval is also given, that is 1.6 and 3. But this is quite large interval, so we try to reduce the size of the interval by again hit and trial method, and we see that interval, the new interval lies inside this interval. So we take value of x as 2.35, function value is negative on this, that is minus 0.03. We take another point 2.37 and see function value is positive. So of course here one root lies between 2.35 and 2.37. So now we use Regula Falsi method and try to get the new approximated root. X2 is equal to, this is the formula, standard formula. We take x0 as 2.35, we take x1 as 2.37, and fx1, fx0 we have already calculated. We substitute the values and get the value of x2, which comes 2.365. This is the new approximated root. Now we check function value at this point and this comes negative. It means our root now lies between 2.365 and 2.37. This is the new interval, and we apply Regula Falsi method again to get new approximated root, that is x3. Now x0 has been replaced by x2, x1 is same, and we substitute all the values again here and then see the value of x3 is 2.365. so we can stop here because our root is correct up to 4 decimal places.